Hello everyone. It's Jenna, and today I'm going to be explaining the CA quiz for week 5 for physics. Okay, so here in this question, it says complete the following sentence to state Newton's third law. Before I even answer this question, what is Newton's third law? Newton's third law is action reaction. What does that mean? So for every action, there's an equal and opposite reaction. This means any force exerted on a body is going to result in an equal magnitude, but in the opposite direction, exerted on the object that caused the first force. So for an example, you push a wall. What happens? The wall pushes you back with the same amount of force, but a different direction, because you're pushing forward, yeah? The wall is going to push you backwards. You know what I mean? Okay, so here, as I said, for every action, there's an equal in magnitude and opposite in the direction reaction. Okay, in this question, consider a force of magnitude 12N making an angle of 35 degrees with the x-axis. So they're giving you this, they're saying that the force is 12 and the angle is 35 degrees. Here they want the horizontal component and the vertical component to two significant figures. What is a horizontal component and a vertical component? A horizontal component, this is the formula. Horizontal, C, we'll just write C. It's Fx, okay? That's the symbol of it. But the formula is F times cos times the angle, okay? And vertical component. This is the symbol, but the formula is F times sine times the angle. Okay? So here they're asking for the horizontal component. The force is 12 and the angle is 35. So horizontal, if the force is 12, 12 times cosine times the angle, which is 35. So here, 12 cos times 35. You're gonna get this. They want two significant figures. So 9.82. Can you round this up? No, so it's gonna be 9.8. And here, they want the vertical component. So it's gonna be 12 times 35. Mm, Sine times 30, which is 6.88. Can you round it up? Yes, so it's gonna be 6.9. Okay. Here, consider a force F of magnitude 10 Newton making an angle of 50 degrees with the x-axis shown below. Here they also want the horizontal component and the vertical component. So our force is 10. And angle is 50. Okay, horizontal is going to be 10 times 50. And vertical is gonna be 10 times 50. Okay. Okay. So 10 times cosine times 50, you're gonna get 6.42, which is 6.4. And the vertical is going to be 10 times 9 times 50 is gonna be 7.66, which you can round to 7.7. Okay. So for this question, match each free body diagram to the description that represents it. Okay. So let's start here. This one, what does T stand for? T is tension and W is weight. We know tension has to do with, what's that called? The tension has to do with strings. So here, which one? Like, okay, a lamp hanging from the ceiling because the tension of the lamp is the string hanging and the weight is dragging it down to the center of the earth. Here we have F is friction, N is normal force, and W is weight. A box resting on an inclined plane. Because the friction of the box is going to an angle, which is the incline, and the normal force is the resting, and W, which is weight, is dragging it to the center of the earth. A ball kicked at an angle by a child because the push of the ball is going to a specific angle because it's getting kicked by the child and the weight is pulling it back. Number 5, the effect of the force along a given direction is called the component of the force. Wait, yes. Okay, what is a component? So we have two types of components, the horizontal component and a vertical component. The horizontal, okay. A component typically refers to a part of a vector or a force that is broken down into its projection along a specific axis, and usually the axis is the x-axis. Number 6, a boy pulls a rope tied to a box with a force T of magnitude 35 newtons at an angle of 60 degrees above the horizontal, as shown in the diagram below. Underline the vertical component and circle the horizontal component. So they gave us the force on the angle, 35 newtons on 60, which is the angle. So horizontal would be, let's calculate it. So horizontal would be 35 times times the angle, which is 60, and we would get 17.5, which is horizontal. And vertical is going to be 35 times 1 times 60, which would be 30.3. So if the vertical is 30.3, then we have to underline it. The horizontal is 17.5. Okay. A man pulls a rope attached to a box with a force F, making an angle of 37 degrees, with the horizontal as shown in the diagram below. The vertical component of the force is 120 newtons. Okay, so how do we find the magnitude? This is the formula for magnitude. Okay, but if they're gonna give you the vertical component on an angle. So if they don't give you the vertical component and the angle, this is the formula you're gonna use. But if they give you vertical component and angle, then you have to use this formula, which is vertical component over angle times sine. So here, since they gave us the vertical component and the angle, then you have to do, what are the numbers? Vertical component 120, and so the angle being 87. Okay, okay. So now we get it on the calculator. First you do 37, you're gonna get 0.6, so 120 over 0.6. You're gonna get 200. And what is the closest to 200 here? Right, which is 199. And the magnitude of the horizontal component horizontal component, so you do the force, which is 199, and horizontal we said the cosine, and the angle is 37, so it's going to be 158.9, which you rounded up to 159. Okay. Newton's third law states that whenever a body A exerts a force F on another body, then B simultaneously exerts on A. A force F equal in magnitude but opposite in direction. Oops, sorry. Okay, number 9. The force exerted by the ball on Earth as it falls is okay. A ball of weight 3 newtons is falling in the air. At some moment, it experiences a drag force of 1 newton. Drag and drop the correct answers to complete the sentences below. The force exerted by the ball on Earth as it falls 3n directed upward because we said it's equal in magnitude but opposite in direction. So instead of it falling down, it's directed upwards because the force is pushing back. And the force exerted by the ball on the surrounding air is 1 newton directed downward. Because what is a drag force? A drag force is is where like an object falls with weight with the resistance, so air resistance. So while the surrounding air, it's directed downwards. Okay. A block is immersed into water and is held at rest by a cord. Drag and drop the correct forces acting on the block to complete its free body diagram below. So they're giving you this, and what force is a block immersed into water and is held at rest by a cord? What is upthrust? Upthrust is also known as the buoyancy force. It's the upward force exerted by a fluid. So here a block is immersed into water and is at rest by a cord. So what would be carrying the block down? Weight. But what would be bringing it back up? It's upthrust with the tension because the cord is a wire. Number 11. Okay, number 11. Two spheres A and B are thrown towards each other in space. They collide, resulting in the momentary forces shown below. What is the magnitude of the force acting on A? So here is A, the white circle, and B is the black circle. And they both are not the same body, and they both act on their own forces. On A, we can see that A is 5 newtons to the right. So they're asking for the magnitude on the force acting A, which is 5 newtons to the right. Why don't they cancel each other? Okay, let me show you something. So if I have A, okay, and I have 5 newtons, 5 newtons. They can cancel out each other because they're both going in different directions and they act on the same body. But then if I have this, they don't cancel out because they're going the same direction, so you add them and they're 10 newtons. Okay? But here, why don't they cancel out each other? It's because they have different forces acting on different bodies. So here, because they act on different bodies. What is the simple representation of the force exerted by A on B? Okay, force exerted by A on B. So it would be written force A, B, which is this one. Number 12. Okay, number 12. Whenever a body A exerts a force F on a body B, simultaneously exerts on A a force F, which is equal in magnitude and opposite in direction. This is the third question that we have, like, that's the same. So, like, I think you guys got the concept. Okay, the last question. Box B is being dragged on a rough horizontal surface S by a force F as shown below. So, it's being dragged on a rough horizontal surface by force F. So, we know that F is friction. Select the arrow that represents the net exerted by the surface on the box F as B. So the force exerted by S on B. And we know that it's equal in magnitude but opposite in direction. So what's the opposite of that one? It's going to be this one. I really hope you guys understood from this. I tried my best to make it simple. And I hope you guys understood. I tried making this video more clear than the math one, and I actually think it was more clear. Thank you for Thank you guys so much for watching. I hope this video was clear enough for you guys to understand. I'll be making more videos like this. And thank you so much. Bye.